All right, welcome back to Mr. Scavilla's YouTube channel. Here we're going to simplify this fraction of radicals. So a lot of different ways you can approach this, all right? First thing I'm going to do is like write it as one radical so I can simplify this fraction. Because PEMDAS, although it's a good method, it is not quite true. Like PEMDAS, you would think means multiplication before division and exponentiation before that. You can actually do the root, square root, which is exponentiation, multiply or divide it in any order, all right? So we're going to, instead of doing like root x over root y, we're going to do root x over y. And that's a property of radicals, so we're allowed to do that, all right? So what that means is now this becomes, well, 234 over 26. Those are both even, so you can cut that in half. So that's going to be 117 over 13. And I think 13 goes into 117. I'm embarrassed I don't know that off the top of my head, but I'm going to check right now. And it does. Nice. That's crazy. All right, we'll come back to that. It's 9. All right, and then x to the 11th over x to the 7th is just going to be x to the 4th. And then y over y is just 1, so that's going to cancel out. All right, so then this becomes the square root of 9x to the 4th, which becomes just 3x squared. So you could have done this a whole more complicated way. You didn't have to do it my way, but it should end up here. And if you ever have two radicals being divided by each other, I encourage you to write it as one radical first and see if that simplifies. Even if it doesn't simplify this nicely, at least it'll reduce what you have here and it'll make the numbers that you have much easier to work with. And we don't need radicals here because it was an even root, but it's an odd it's an even exponent. So if this was x to the first or x cubed or x to the fifth, then you would need absolute values. But this will be positive no matter what, so we're good.